Algebra 2. This is Unit 10, Lesson 5, and today we're going to talk about rational functions. So rational functions are just the ratio of polynomial functions. They take on more interesting properties and have more interesting graphs than polynomials because of the interaction between the numerator and the denominator. So we're going to look at primarily the algebra of these functions, but let's look at some of the basic characteristics of them. So in exercise 1, we have a rational function f of x equals x plus 6 over x minus 3. In A, we just want to find the y-intercept for this function. Remember the y-intercept, that's when x equals 0. So I'm going to plug in 0 for x, so it's going to be 0 plus 6 in the numerator and 0 minus 3 in the denominator. And that gives me 6 over negative 3, which is negative 2. Okay, so that's how I do it algebraically. Graphically, you would just put it into your graphing calculator. Algebraically, determine the x-intercept of this function. Hint, a fraction can only equal 0 if its numerator is 0. All right, so the x-intercept, okay, that is basically when y is equal to 0, okay? But a fraction can only equal 0 if its numerator is 0. That part is important right here. So the numerator equals 0. So all I have to do is to take that numerator, that's the top, and set it equal to 0 and solve. So x equals negative 6. Okay. For what value of x is this function undefined? Well, we already talked about this year. It's undefined when the denominator equals 0. So I'm going to take that denominator and set it equal to 0 and solve. Okay, you can't divide by 0, so a fraction is undefined when the denominator equals 0. Based on C, state the domain of this function in set builder notation. So the only time this is undefined is when x equals 3. So it's all values of x such that x does not equal 3, but anything else is okay. All right, exercise 2. Find all the values of x for which the rational function h of x equals x plus 5 over 2x squared plus 11x minus 6 is undefined. Remember, it's undefined when the denominator equals 0. So I'm going to take that denominator and I'm going to set it equal to 0 and solve. So you guys should be good at doing stuff like this right now. You guys are probably doing the AC method, all right, because I have to, in order to solve, I have to factor this. So I'm going to multiply 2 times negative 6 is negative 12. So now I'm looking for the factors of negative 12 that will give me a positive 11x, and that's going to be a 12x and a negative 1x. So I'm rewriting that 11x in the middle as positive 12x and negative 1x. All right. So I now have 4 terms and I can factor by grouping. So I'm going to pull out a 2x and I'm left with x plus 6. And then I'm going to factor out a negative 1 and I'm going to be left with x plus 6. Okay, so remember, I'm factoring these first two, GCF, and then I'm factoring the last two. I group them together. Now those GCFs get pulled together to become a factor. So again, I'm just pulling together the 2x and the negative 1, the GCFs, they're a factor, and the other factor is x plus 6. And then I take each of these factors, do it up here, and I set them equal to 0, and I solve. And x equals 1/2. So basically when x is 1/2 or when x is negative 6, that function is undefined. All right, which of the following represents the domain of this function? So the only problem that we have is when the denominator equals 0. So I'm going to take this denominator and I'm going to set it equal to 0 and solve, because those are the values that cannot work. Again, it's a trinomial. This one doesn't have a coefficient, so I'm just going to factor it. So I'm looking for the factors of 16 that combine together to give me negative 6. Well, 8 and 2 multiply to 16, and if it was a negative 8 and a positive 2, that would work. So then I set each factor equal to 0 and solve. Again, these are the numbers that are not going to work. So all numbers work except for when x is 8 and when x is negative 2. Right? Now this was multiple choice, so I also could have just plugged in those choices to see which one was working. All right, exercise 4. G of x equals 3x minus 2 and f of x equals 2x plus 1 over x plus 5. Find f of g of negative 2. So basically we've done the composition. I'm going to do g of negative 2. So I'm putting in negative 2 in the g function. So that's negative 6 minus 2, which is negative 8. And then I'm going to do f of negative 8. Okay, so f of negative 8 is 2 times negative 8 plus 1 over negative 8 plus 5. That's negative 16 plus 1 is negative 15. On the denominator, negative 8 plus 5 is negative 3, so that equals 5. Let me change colors for this one. So now I have f of g of 2, so again I'm going to do g of 2. 3 times 2 minus 2 is 4. And then I'm going to do f of 4. So 2 times 4 plus 1 over 4 plus 1. So that's 8 plus 1 is 9. And 4 plus, I'm sorry, this was a 5 down here. 4 plus 5 is 9, which is 1. Okay, and this last one here, f of g of x. So basically, I am going to substitute g of x in for f for wherever there's an x in the f of x. So I'm doing g of x is 3x minus 2. So I'm doing f of 3x minus 2. Okay, so 2 times 3x minus 2 plus 1 over 3x minus 2 plus 5. So all I did was take the f of x, okay, which is right here, and wherever there was an x, I plugged in 3x minus 2. Well, I have to distribute this, so that's going to give me 6x minus 4 plus 1, and on the bottom I'm going to have 3x plus 3. I just combine the negative 2 and the 5. On the top, the negative 4 and the 1 is really going to be 6x minus 3 over 3x plus 3. Both of those have a GCF of 3, the top and the bottom, so I can actually pull out a 3. And I'm left with 2x minus 1 on top. And if I pull out a 3 in the bottom, I'm left with x plus 1. And then the 3's cancel. All right, so actually, I'm left with 2x minus 1 on top and x plus 1 on the bottom. And that's my answer. All right, number 5, I'm going to do the inverse. Remember, for inverse, you have to switch the x and the y. So these inverses are just a tiny bit more tricky. So wherever there's a y, I'm putting an x, and wherever there's an x, I'm putting a y. So I switch the x and the y's, and then I have to solve for y. So I'm going to put a 1 under here and cross multiply, and I'm going to have 1 times y is y. And then on the other side, I'm going to have x times y is xy, and x times negative 2 is negative 2x. All right. And I'm going to bring this 2x over to the other side. All right, I want to bring everything with the y's to one side and everything without the y's to the other side. So I'm going to bring the y over to the right, and I'm going to bring the x over to the left. So on the left, I'm going to have 2x, and on the y, I'm going to have xy minus y. All right. And then what I'm going to have to do is I am going to factor. So I'm going to factor out a y on the right, all right, and I'm left with x minus 1, and then I can finally get y by itself by just dividing by x minus 1. So again, here's what I did. I switched the x and the y's, all right, and then I cross multiply. I'm solving. I want all terms with y's on one side and all terms without y's on the other side. And then I was able to factor out the y, and then to get y by itself, I just have to divide by that x minus 1. So basically y equals 2x over x minus 1. All right, let's try b. So I'll go a little bit slower. So x equals y plus 3 over 2y. Switch the x and the y. Cross multiply. 1 times y plus 3 is y plus 3. That's on the left, and x times 2y is 2xy. Now I want any term with a y on one side. So let's leave the 3 over here, and let's bring that y to the other side. So I'm going to have 2xy minus y. So I want all terms with a y on one side. Well, on that side, I'm going to factor out the y, and I'm left with 2x minus 1. Now, once you have that y factored out, I can solve for y by just dividing by 2x minus 1. So my answer is y equals 3 over 2x minus 1. All right, so some stuff that we did before, but now obviously it's a little bit harder because of the fractions. All right, and last one, I have a function f of x equals x squared minus 8 over 4x. It's either an even or an odd function. Determine which it is and justify, based on your answer, which type of symmetry must this function have. Use your calculator to sketch a graph and verify. Okay, so remember, even functions, opposite inputs have the same output. Opposite inputs have the same outputs. So when I substitute in that negative x, I'm going to have the same output that I did for a positive x. Odd functions, opposite inputs have opposite outputs. All right, and also remember, graphically, even functions are symmetric across the y-axis, and odd functions are symmetric across the origin. All right, and also I'll add this. So f of x equals f of negative x, and on the other one, negative f of x equals f of negative x. They have opposite outputs. All right, so let's look at this. So I'm just going to take a number, like maybe 4 I'll take, f of 4. So f of 4 is 4 squared minus 8 over 4 times 4. Well, that's going to give me 8 over 16, which is 1/2. Now let's try f of negative 4. So I have negative 4 squared minus 8 over 4 times negative 4. Well, that's going to give me 8 over negative 16, which is negative 1/2. All right, so they have opposite outputs. So this is an odd function. Opposite outputs give opposite inputs. Let me erase that. Opposite inputs give opposite outputs. Now this should have symmetry across the origin. Now let's take this and put this into our graphing calculator so we can see what it looks like. All right, so I'm going to put this in Y1 to see what it looks like, and we'll talk about graphing some more in a different lesson, but it looks something like this. And then I have one of them going like this. All right, and again, I did that from my graphing calculator. So symmetry across the origin means I can turn it upside down, and it's the same thing upside down. All right, and that is it for today. So we'll practice all that tomorrow, talking about domains, talking about inverses, and we'll practice it all.